sit back, relax, and learn all you can. We'll have a session for questions right after. So the next voice you'll be hearing from now is Chinemezie. Hi, Chinemezie. Thank you for joining. You have the floor.
Thanks, Tony. Good evening, everyone. So I don't know, can you hear me? Please confirm if you can hear me.
Yes, I can hear you.
All right. So you're all welcome to this session. So I'm really excited to take us on this topic because this is one of the most important topics in this our time. So you can see here Git and version control best practices. So I'm Chinemezie ThankGod, full stack engineer, cloud engineer. So let's start from here. So what is Git actually? From our screen, we can see that Git is a version control system. So when we hear of version control, what comes to our mind? So it's just a way of tracking and managing our source code. You know, most of us here are developers. So I believe we must have used Git at some point in our lives. And one very important thing that Git has come to help with is the DevOps culture. So recently we have noticed that there's a lot of, we hear a lot about DevOps. Though the Nigerian ecosystem has not really imbibed DevOps fully, but you can see that if you look at the West, you can see that DevOps has become one very potential area, and Git provides the first stage of DevOps, which it helps in automation. So Git is actually a very powerful tool, but I wouldn't like to start giving us too many details about Git. Let me just, what was life before Git? Because for you to really appreciate the importance or what Git has come to do, you need to know exactly what was life before Git, like how a developers handling their source code and managing their source code before Git came about. So from this diagram, we can see a lot of things. So if you can see here, so we can see here central server. We can see developers, developer 1, developer 2, developer 3. So you will notice that all these developers commit their codes to a central repository, like a central server. So there are a few issues with this kind of system. One of the issues you can see here, okay, can anyone, sorry. Please, I would like this session to be a little bit interactive. So looking at this now, can anyone just spot out 1 or 2 issues you can see from this diagram? Yeah, the floor is open, please. Hello? Is anyone here? Hello, can you hear me? Wow.
Yes,
I can hear you.
I hear you. Can hear you.
So yeah, so from this, just spot out one issue that you see from this. Oh, okay, someone I can see. Okay, so please, can you just spot out an issue from this, because this is live before Git came. Okay, I will have to spot it out myself. So you can see here that developer 1 and developer 2 do not have a way of communicating. So there was a problem with communication. That's number 1. Then developer 1 had to commit his code to a central server. He himself will not have a copy of that code once he has committed it. So he will have no way to have a copy of what he's committing. That's another problem. And then if developer 2 makes changes to this code here, developer 1 will not know what changes developer 2 has made to this. So you can see the problem of collaboration, communication, and also the problem of a single point of failure. So we are having a central server here, which is a single point of failure. And there is no way to track your changes. If this developer commits to this, he does not have a copy of it. So what happens if this server goes down? You see that there's a problem. So with these few points, you can see that, okay, now, what does life after Git look like? This is life after Git. You now see that we have a repository that is distributed. Distributed in what sense? Developer 1 has a copy, developer 2 has a copy. You can see developer 3 has a copy. Each and every one of them, for every change that one makes, all this one needs to do is just git pull and have a copy immediately. And this one just git pull and have a copy immediately. So you can see that we now have a distributed system. So no particular person has, let me say, has the full power over this repository. So you can begin to appreciate what Git has come to do. So why Git? So a lot of things that Git has come to do. Git has improved the speed of development. You know, now you don't, as I said before, Git is a DevOps tool. So as a result of Git, we can now commit codes directly and even deploy to a server just by one click, just by git push, just git pushing, and you have even deployed to a server directly, which was not possible before. So it has improved the speed of code of development and deployment. So it's an open source tool. It's available to everyone. You can just go to where you can download it and have it on your system. It's distributed, as I said, distributed. So no one person has it. Everybody can have his own copy of the same thing. You understand? So it is highly secured. It is scalable, which means that it doesn't matter how much code you are writing. No matter the workload, no matter all these projects like Facebook, all these big projects, it scales. So even if you are increasing, no matter the amount of code you are writing, it can still be managed by Git. So it offers branching, data assurance. It offers what we call a staging area. I will explain more about this staging area. It has a local repository. It enables collaboration, as I said before. It offers you a clean history. You know, you can always check your history using the git log command. So now, okay. So now, Git, please, who is okay. So Git, please, can we meet the person that? Okay. So Git has a workflow actually. So we have our working directories. Okay, I think I should open. Oh, sorry. Sorry. So Git offers us a staging area, a local repository, and also a remote repository. But before I can explain all these things, let me just make this clear difference. There's a difference between Git and GitHub. You know, so many people make that mistake of confusing both. So GitHub is just a company that provides a hosting service, just like you have AWS that provides hosting services for developers. So you can write your code and host it on GitHub. But Git itself is a version control system. So you can download it on your system and it begins to control the different versions of your source code that you produce. So that's the difference. GitHub is just a company that provides you with hosting services for your code. So whenever you go to GitHub, all you can do there is like host your codes for others to view, or also maybe if you have a problem, let's say your system crashes, you can still have all your code on your GitHub. So that's just clear difference between those. Then you can see here Git versus GitHub. So you can see that Git is installed and maintained on your local system rather than in the cloud. whereas GitHub is on the cloud. It's not on your own system. So let's imagine that you have code on your system and it crashes. You can still get your code on GitHub if you had pushed it. So Git offers branching, whereby you can be working, you can create a branch, you can check out into your own branch and begin to do what you want to do. Then later, it could be merged to the main branch. So you can share your code with others through GitHub. So GitHub allows you to share. You cannot share your codes that are within your local system, but it's this code that you have pushed to GitHub that you'll be able to share. So it is exclusively cloud-based. GitHub is exclusively cloud-based. So, but this Git is on your own local system. So that's the main difference. GitHub is a cloud-based system, while Git is the one you install in your system. So that's it. And then we move. So what are the best practices when using Git? Commit changes atomically. What do you mean by that? Let's imagine that you are working on a project and you are asked to fix, let's say you are working on a front-end project and you are asked to fix, let's say a particular button. Yeah. So you need to commit it in such a way that everything that is required for the button to be fixed, they must be all like, you must make sure that the button has been fixed before you commit. So you don't just commit when maybe you are halfway. You have made a change, but you are halfway and it's not complete, and you just do Git commit. No, you have to make sure that you have done what you have been asked to do completely, and you are sure your task has been completed before you can do a Git commit. So that's what I mean by atomic. It must be full, not broken down. So commit files with a single purpose. What do I mean by that? If you are given a task, let's say add button, let's say add text field to so and so page, you are expected that when you add the text field, you do a commit saying that you have added the text field. Not you add a text field, add a button, add this, add that, add this. And then at the end of the day, you don't even know what to name that particular commit. So each commit should have, it should be for a single purpose. It makes it easier when you want to fix bugs. So let's imagine you want to fix a particular button issue that you have on your front-end project. You have to fix that issue only and commit it and give it a proper message. That's where write a good commit message. The reason why you need to write a good commit message, when you say git commit message, you need to give it a name so that if it breaks, you should be able to track the version that caused it to break using your commit message. If maybe you say this commit message is fixing a bug on page this. So there's a way that something will happen. We should be able to get back to the problem that caused it, or what caused the issue. So that is what we're talking about here. So these three go together. So if you don't commit files with single purpose, it will be hard to give it a good commit message. Some people will just say, git commit, my commit, or my first commit. No, that's not a good message. The message should tell exactly what you did. Is it an addition? Is it a fixing? Is it a modification of a file? You need to say, okay, modified text.txt or added this. So there must be a clear message. There must be a clear message to the. I'm trying to take us to something here. I don't know why it keeps. How do I get back to my normal page? Hold on. Sorry. Okay, so the next one is do reviews before committing to a shared repository. So, when we are working on a project, a large project, we have the main branch, then we have other branches. Each you can have feature branches where each feature branch is a particular feature that a particular developer is working on. So before it can be merged to the main branch, there must be a code review to avoid breaking. So if you have worked with the DevOps lifecycle before, you understand that a single break can cause a lot of things on the server. You know? So say make sure every commit is traceable. If you don't give the commit messages, if you don't give them a good message, you will not be able to trace every commit. That's why every commit must have a very good message. You must be able to tell what exactly are you doing? What did you do in this commit? So that is just it. Then commit often is very important. So when you commit often, it helps to avoid conflicts. For every single change that you make, you must commit. Let's say you just fixed a bug, commit that little change. Don't wait until you have had so many changes before you can now commit. Because at the end of the day, if something breaks on the server, we will not be able to trace back, okay, what caused this, what caused this. No. But when you change a particular thing and you commit, if there is a problem, we can roll back immediately to the old version. So that's why you must commit often. So you can use git ignore wisely. Some people don't know about git ignore. Git ignore is, okay, if I'm pushing to my repo, let's say my GitHub repo, what are those things that git should ignore? For example, you will have your .env file. The .env file is where you put all your secret keys, your database name, all those kind of things. These are things that you shouldn't make public. So it is wise that you put them in your git ignore, so that when you are pushing to your GitHub repo, it will not be seen. So it will not be pushed with it. So always use branches. You know, branches are very important when working on different features. So it is only when what you have built has been approved or reviewed to be fine, that is when it can be merged to the main branch. So I just want to show some things here. I will have to. Okay, fine. I was looking for how to do this. So can everyone see my screen? Are we still here?
Yeah, carry on.
Okay, seems like I'm alone here. Okay, so so I wanted to explain something about the GitHub Git workflow. So anytime you make a change, it's just a Node.js TypeScript project. So I will make, okay, for now, let me check. It's in Git status. So I can check here. Now, what this thing is telling me is this. It's telling me that my working directory has made these changes, which have not been added to my, staging area. So whenever you make a change to your code, it is your working directory that you make changes to. So if you want to add it to your staging area, that's when you use the git add command. And when you use git add dots, it means you are adding everything. If I want to add it one by one, I'll have to start calling and say package.json, this and this. So but with the dots, dot means look for the files that changes and then add it to the staging area. So once I do git add, it adds it. If I do git status, you can see it now telling it has turned to green, telling me that it has added it to the staging area. So now, whenever you say git commit, so here now I will say modified the user.cs file. You might as well tell us exactly what you modified. Yeah, to make it. I say I modified line this, I added this to this. So once you commit, this git commit is going to move it from the staging area to the local repository. So git commit moves it to the local repository. So it has added it to the local repository. So when I do git push, what it does is that it moves it from the local repository to my GitHub, the remote repository. So that is just the Git workflow, starting from the working directory to the staging area, the local repository to the remote repository, which is the GitHub repository. So that is basically it. And yep, coming to the end of my presentation. So I don't know if you have any questions, but that's why I ask. Be clarified. Hello.
Okay. Good afternoon.
Good afternoon.
I don't know if I.
Hello.
I
Can hear you. Can hear you.
Can I be heard?
Hello.
Go ahead.
Hello,
We
can I
can
be
hear
heard?
you. We can hear you. Go ahead, please.
All right. I uh, I want to ask a question because I tried committing. I did this task, the Model 3 task, and then I tried committing it on the GitHub. And after trying the test, I discovered that it was saying that the .txt file I created is not there, that they could not recognize it. The system was saying that it could not recognize the file. So I don't really know what happened or what could be wrong. Why is it giving me such a message? I think it was saying something unary operator or something like that command. I don't really know.
I think that kind of problem is usually handled during the Bookie. Are you here?
Yeah, I'm here.
I think these are the issues that are usually handled during, is it on Tuesday or what?
Yeah, on Tuesdays.
Yeah, this one is a different thing. I mean, we'll still look into your problem, but for now, I will only entertain questions that pertain to what I have actually presented. So we'll still look at your issue, but this session is not really for that kind of, I think it's another day for that.
Can I ask one or two questions?
Okay, go ahead.
Favor, is that favor, please? What's the question?
Okay.
I was the one. I was the one.
Okay, what task are you on?
The Git version, Git control version.
We just got there. We normally have
No,
coding checking. Sorry?
I've been there for quite a while now.
You always see the note. There's always this notification for Tuesday's coding checking. And it's for people that have issues. They'll come on board during the session. And if you have any issues, you come on board. But I don't think I've seen your name does not ring a bell. And besides that, you can always reach out. There are notices. I don't know whether you read your notifications. When a notification is sent to the channel, I don't know whether you read your notifications. If you do read your notifications, you will see who you can reach out to. So that's it. So you just always read when there's a message comes in. You should please. Which track are you on?
The full stack.
Yes, and I'm sure you're on the channels. So please don't hold back and don't wait. You say you've been on this for a long time. You don't have to wait for this. You can always reach out, please. So you can always reach out to me. Sorry?
I think this is the first time I'm seeing these notifications.
Sorry?
I think it's the first time I'm seeing the notification for let's say, a session like this.
No, it's not just about this. Don't you receive notifications when there's a message that is sent on the channel? Don't you see the messages?
I think this is the first one I'm receiving, actually.
This is the first one you're seeing. Hey, you can always reach out to me after reach out to me, please. You can always reach out to me after this program. Let's not prolong this. My name is so don't reach out to me at Bookie.
Okay, man. Thank you, man.
Right. So, any other question?
I think Paul is raising his hand.
Hello.
Yeah.
Hello, sir.
Hello.
Yeah. Good afternoon.
Good afternoon.
So, thank you. Nice to meet you again on this space. So,
nice again. Have we met before, bro?
Yeah, we met before. Probably you've not seen my name.
Okay, what's the name?
This is Paul Ezemiwe.
I went to school to do
Oh.
something. That's why.
Okay. Yeah, we have met before. Okay. Your questions.
Okay, so I really want to say a big thank you to the organizers of this meeting. So really, you've done a good work, and I just want to draw your attention to some things. So I wanted to ask about how Git works. So there is in the file, once you do your Git init, you see this .git file added, hidden. So you don't get to see it. Yeah. So I want to ask, is there anything it does? Like what has that got to do with your Git tracking? So
This
then
file,
also
right?
I also like the point you gave for the .git ignore, because my first time using React, I didn't know node modules was to be added to .git ignore. So are there some other things apart from .env .env node modules that you can just enlighten us on that should be added to .git ignore? Yeah, the third one I can't remember. Maybe later I'll get to remember.
Okay. So actually, when you do git init, you see this .git file created. It is this .git file actually that handles all the tracking. You know, when everything about the tracking of your project is done here within this .git file. So it is the .git file that handles the tracking of your project. So now you can see that you are it. Sorry. So you can see what is within this .git file. We can see the head. This is what your current main file, that is the main, is pointing to. We can see the index. We can see the logs. We can see all this. So when you do git add, it adds it to the staging area, right? Actually, which is handled within this the git file. So what the .git file does actually is to manage both your staging and your local repository. So once you have done git init, the .git file is created immediately. Wait, let me do something. New folder. Okay. So let me just create a new folder here. Test folder. So okay, so let me just create index.txt. So we have an index.txt file here. Okay. So for now, we do ls/la. We can see that there is there is nothing here because I've not made it I've not initialized git. So but what happens when I do git init? Good. So now if I do ls/la, you will see a difference. You see, this appears. This is what handles the tracking. So you see that it has added this git. So if I do ls.git/, you see everything that is inside here. So this is just the configuration for what it uses to handle both the staging, working directory. So when you do git add, it pushes it to one of these folders. I did not really look at it. I've forgotten some stuff here, but so it is just within here that it handles everything about your Git. So it is this file that matters here. So if this file is not here, there will be no tracking. There will be no way of tracking this folder, and immediately it has set it to master. So that's basically what this .git does. And then the .git ignore. You said, is there another way of this? Can you repeat your question, please?
Yeah, so for .git ignore, like you said, things like .env, files like .env.
Yeah.
So I said for myself, like one mistake I made when I started React was that I never knew you're not supposed to push your node modules to the remote. So you just add it to .ignore to exclude it. So I was saying, are there some other files that should be like that we should know that should be excluded with .git ignore?
Yes. Your .env file that contains things that wouldn't be. Let's take example now. Your database. Let me go back to what I had here. Open recent. I sent this. Okay, so you can see here I have a .env file. So now, you can see I have to make this stuff secret. So I can't push this because if anybody gets this stuff, they'll be able to log into my database and mess things up. Even this secret token something, which is, it allows people to log in, like make API calls. So if a person is not authenticated, he will not be able to make some API calls. But if someone can get this, a hacker can get this, he'll be able to make any API call to my server and get what he wants to get. So that's why you just have a .env file. You put all your stuff there so that it can work while you are still on your local system. But when you are pushing it to GitHub, you will have to exclude it in your, you can see, I excluded the .env, the node modules, then this other one for a particular reason. So I don't know if I answered your question.
Yeah, you did. Thank you very much. The third one is not a question. It's just that I think we'll need more on conflicts, like conflict with. Yeah, that's all.
Okay.
Thank you.
Okay. Yeah. You're welcome. Any other question? Hello, any other question? Also, I want to state that Git is very, very important when you start dealing with the DevOps cycle. Without Git, it will not be possible to have CI. This CI, continuous integration, is possible because of Git. Though we have other, so Git makes CI very possible. So today, developers don't really need to bother themselves about going SSH into a server, then deploying their stores by themselves. Once they push to Git, every other thing is handled and the project or the API is deployed on the server automatically. So you see that Git has come to ease life for we developers. Do you have any other question? Tolu, it seems like we don't have questions anymore.
It seems like we don't have any other questions. If that's the case, I want to thank you, Chinemezie. Thank you very much for taking this opportunity to help teach and show us some of these things that are beneficial about this. Thank you so much. And thank you everyone for tuning in, for joining in today. Like I said the other time when we were about starting out, we've now had Dufuna talks in the past 2 weeks. I think there was a public holiday and then there was one where our speaker was not feeling very, very well. So, but if this is your first time joining this session, we have Dufuna talks every Friday, barring public holidays. We have Dufuna talks every Friday. So next week Friday is another opportunity to join in and learn. And also we encourage that you participate in other community programs. I think Favor has left now. We always announce programs, different programs like the coding check-in. The coding check-in session is the opportunity for everyone on the um, coding track. That's the front end and the full stack to come and ask questions, to come and resolve blockers that they may have encountered during their learning process. And then we also have the design coding check-in usually takes place on Tuesdays by 4 p.m. We also have the design and the product design and product management check-in session. That one is scheduled for Wednesday by 4:30, from 4:30 to 5:30. And that is also like the coding check-in, but this time for the designers and the product managers. So please take part in community-led programs. We also have the hackathon and the designathon. That one is a monthly program that it's like a competition where people are divided into product teams. These product teams will have developers, designers, and managers, and everybody will work on projects basically. And at the end of the day, we have a review session where all projects are reviewed, and all of these things are channeled towards helping you get better, helping you add more skills, basically. So please participate, be an active part of the community, all for our benefit. All right, thank you so much for joining in today. I'll be bringing an end to this session now. Have a wonderful weekend ahead. Thank you. Bye, everyone, for now.
Bye, thanks.
Mhm.